New telescope images have revealed a remarkable and dramatic sight in our solar neighborhood. The interstellar comet 3I/Atlas appears to be shooting a massive jet of gas and dust directly toward the sun. Although this might sound strange or even suspicious to some observers, astronomers emphasize that this is completely normal behavior for comets, especially ones that are approaching the inner solar system. The newly released images, which come from the 2-meter twin telescope TTT at the Tide Observatory in Spain's Canary Islands, give scientists their clearest look yet at this rare cosmic traveler, only the third interstellar object ever detected passing through our solar system. The comet, discovered in late June and confirmed by NASA in early July, is believed to have originated in another star system far beyond the boundaries of our own. At an estimated width of between 3 and 7 miles, 5 to 11 kilometers, it is significantly larger than previous interstellar visitors like Oumuamua and Comet 2I/Borisov. Not only is it the largest, but given that it likely formed billions of years before the birth of our sun, scientists consider 3I/Atlas to be one of the oldest objects ever observed in interstellar space. Its size, age, and unusual trajectory have naturally sparked scientific interest and speculation alike. A small group of researchers, often those on the fringe of mainstream astronomy, have suggested that these characteristics might indicate something artificial, even proposing that the object could be an alien spacecraft or probe sent to observe our solar system. However, the overwhelming majority of astronomers strongly disagree with these claims. They point out that all available data shows the comet behaving exactly as a natural, icy body should when heated by the sun. Nothing in its motion or composition suggests technology or intelligent design. Instead, the latest images reinforce the explanation that 3I/Atlas is a typical comet undergoing familiar physical processes as it approaches perihelion, the closest point to the sun in its orbit. The image released on the Astronomer's Telegram on October 15th is a composite created from 159 separate exposures, each lasting 50 seconds. When combined, these exposures reveal a bright, glowing coma surrounding a dark, shadowed nucleus. The nucleus appears as a large black that because it is too faint and too small to be clearly resolved at such distance, even with a powerful telescope. Surrounding this nucleus is the comet's coma, a cloud of gas and dust that forms when sunlight warms the surface and causes frozen materials to sublimate directly from solid to gas. What makes the photo especially striking is a sudden fan-shaped break in the otherwise uniform glow of the coma. This bright, triangular feature marks the point where a jet of high-speed material is erupting from the sun-facing side of the comet. Researchers highlighted this feature in the release image, marking the direction of the jet in purple to draw attention to its shape and orientation. Comets are well known for producing glowing tails of ionized gas that can stretch for millions of miles in the opposite direction of the sun. This anti-solar tail is pushed outward by solar radiation pressure and the constant stream of charged particles known as the solar wind. Jets, however, are smaller-scale phenomena that burst from specific weak points on the comet's surface. These jets often aim roughly toward the sun because that is the direction where the surface heats most rapidly. According to Miguel Serra-Riquet, an astrophysicist and chief science officer at Tide Observatory's Light Bridges Research Institution, the process is straightforward. As a comet comes closer to the sun, its icy surface absorbs heat. But the heat does not spread evenly. Some regions remain colder, while others, especially those facing the sun, warm up quickly. If one of those warmer regions contains porous or fragile material, pressure can build beneath the surface as subsurface ice sublimates. Eventually, this pressure forces the gas and dust outward through cracks or vents, creating a jet that can shoot thousands of miles into space. Serra-Riquet explained in his email to Live Science that this phenomenon is routine and expected. Jets nearly always face the sunward direction, while the comet's longer, more familiar tail points away from the sun. As the comet rotates, the jet's direction relative to observers can sweep across the coma, creating a fan-like structure similar to the one seen in the new TTT image. This fan shape has been observed in numerous comets, throughout history. For example, Comet Neowise, one of the brightest naked-eye comets in recent years, displayed similar sun-facing jets during its 2020 approach to the inner solar system. Images captured by the Hubble Space Telescope at that time showed jets that spread out in curved, sweeping arcs as the nucleus rotated. The material released by such jets does not all behave the same way once it leaves the comet's surface. Some of it contributes to the coma, replenishing the cloud of gas and dust that gives the comet its fuzzy appearance. Some of it is carried into the solar wind, where it may eventually join the comet's tail. And some of it simply disperses into surrounding space. This complex interaction between jet activity, rotation, radiation pressure, and solar wind helps explain why comets often display multiple structures, even simultaneously, such as a sunward jet, an anti-solar dust tail, and a separate ion tail. None of this requires any form of advanced technology or artificial mechanics. It is, in fact, one of the most well-documented and well-understood processes in comet science. Although scientists do not yet know the exact length or expansion rate of 3I/Atlas newly observed jet, Sarah Rickett estimates that the feature may stretch roughly 6,200 miles, 10,000 kilometers, outward from the nucleus. This is enormous by human standards, long enough to span the distance from New York to Tokyo multiple times, but relatively modest compared to the largest comet tails, which can be hundreds of millions of miles long. The jet is likely composed of dust particles mixed with sublimated carbon dioxide gas. This matches the observations made earlier in August by the James Webb Space Telescope, which detected a large plume of carbon dioxide and dust surrounding the comet. CO2 sublimation plays a major role in comet activity at the distance 3I/Atlas is currently traveling, making this composition entirely expected. The interstellar visitor completed a close pass by Mars on October 3rd and is now approaching its perihelion, which it will reach on October 29th. At the moment, the comet is on the far side of the Sun from Earth, making direct observation impossible. It will not become visible again until mid-November, when it emerges from behind the Sun's glare. Astronomers are eagerly awaiting this moment because they will have a rare opportunity to study how the comet has changed after experiencing the intense heat and radiation of its close solar encounter. Jets like the one seen in the TTT images may increase, multiply, or shift orientation depending on how much of the surface cracks or fractures during heating. The comet's tail may also grow significantly in length and brightness. Because interstellar comets are exceedingly rare, each new image and measurement provides invaluable data about the composition of distant planetary systems and the conditions of the early universe. As scientists prepare for the comet's reappearance, excitement continues to grow within the astronomical community. Every observation of 3I/Atlas adds a new piece to the puzzle of its origins, its journey, and the forces shaping its behavior. While speculation about alien technology makes for dramatic headlines, the true story of this ancient object is far more profound. It represents a fragment of a long-forgotten world, formed in the cold darkness around a star that may no longer even exist. Its presence in our solar system offers a fleeting glimpse into the vastness of interstellar space and the cosmic processes that have been occurring long before human beings ever looked up at the sky.